Hi, thanks for joining us for Discovery Lab Online with the Fort Worth Museum of Science and History. My name is Anne and I work at the museum, and we are so excited to do science and math and history with you through our program. Join us every day on our YouTube channel for new videos to be released. This program is Geometric Transformations, and it's a hands-on math program. Let me show you the supplies you're going to need. All you're going to need for this program is a pair of scissors, some clear tape, a pencil, and then you're going to need, for right now, just one sheet of paper. And we're going to cut it into strips in just a little bit. Transformations are a beautiful part of geometry where we take shapes and we move them, rotate them, flip them to make them change. We're also going to be playing with this wonderful loop at the end of our program. And so in this program, we're going to be transforming pieces of paper into surprising shapes. We're going to use a skill in mathematics called visualization, which reminds me of predicting in science. And we are going to make lots and lots of loops and cut them in fun ways. So let's get started. You're going to need that piece of paper. It doesn't have to be white. It can be construction paper. It can be anything. What I'm going to ask you to do is cut it into strips. And I'm going to ask you to make those strips about 1.5 inches wide. Now, before you grab a ruler, you don't even have to grab a ruler for this. There's nothing magical about the width of the shapes. But I will let you know that for most people, depending on your age, that 1 or 2 knuckles is about 1 inch to 1.5 inches. So let's go to the document camera. I'll be using a document camera for our program so you can see what I'm doing with my hands. And so I've got this piece of paper, and all I've got to do is cut some strips. And so grab your scissors. I'm going to grab mine. And then I'm going to make some strips of paper. I will admit I cut the paper ahead of time as well. Now you may find after today you'll want to do more and more experiments with this, and all you need is the paper. Again, the strips there's nothing magical about the width of the strips. Anywhere between 1.5 inches to 2 inches is just great. You usually can get about 6 strips of paper per page, and you want to cut along the long end of the paper. And as you can tell, mine aren't all that straight, but that's okay. For our first transformation, we are going to take one of our strips that's flat, and we're going to transform it into a loop. It's pretty simple. You just bring the 2 edges together, and then I want you to tape it in place. So we've taken that flat rectangle, and now we've made a loop. We're using recycled paper at our museum, so that's why you see the writing. Now, if I was to ask you about your shape, and we can go back to the main camera. If I was to ask you about your shape, I'm curious to know how many edges your loop has and how many sides. I want you to think about that. How many edges can you feel? I feel an edge on the top, and I feel an edge on the bottom. So I would say this shape has 2 edges. Now let's figure out how many sides it has. And for that, you'll need your pencil or marker. And we're going to go back to the document camera. I'm going to show you what I'd like you to do just to find out how many sides we have. So I'd like you to take your marker or your pencil, and on the inside of the loop, I want you to make a big dot so you can see it and find it easily. Now we're going to make a line of symmetry down the middle of the paper. I know that sounds fancy, but all that means is you're going to draw a straight line down the center of the paper until you touch the dot again. Now, a line of symmetry is just a line that divides an object into 2 equal pieces, and that's what we're doing right now. And one question you might have is, do you go over the tape? Yep, you go over the tape and touch the dot. Now, this is a proof. And it proves to me there's an inside where there's a line, and there's an outside where the line doesn't go. So I would say this loop has 2 edges and 2 sides, an inside and an outside. Now my next question for you is this. If we were to cut along that line, what are you going to end up with? Now I know this sounds silly when you're looking at a computer screen. I want you to close your eyes, and I want you to use a skill that mathematicians use all the time. It's called visualization. And I want you to visualize cutting this with a pair of scissors. And what are you going to end up when you're done? The work inside your head is really important before you do the work with your hands, so don't grab those scissors yet. Imagine or visualize what it looks like. All right, let's try it. I'm going to go back to the document camera because there's a special way I want you to cut all the loops we do today. I want you to take your loop and I want you to smush one end of it. And right where you smushed it, very fancy word there, I want you to make one cut with your scissors and then stop. Reminds me of a little duck's mouth. And I want you to open it up, put your scissors on the inside, and cut all the way around. And I want you to cut on that line of symmetry that you made. And let's see what you get. And you do cut over the tape. I bet you got the same thing I did. You got two loops. They're the same diameter, same circumference, but they are half the width because we cut along that line of symmetry. So that's our first transformation. Pretty simple, right? Now we're going to get a little more complex. And for this next transformation, I need you to get two pieces of paper that you've already cut, and I want you to make two separate loops and tape them together. I'll put them on my document camera for you. Now, some people may know, like at holiday time, you make chains made out of construction paper that you can put on Christmas trees or other things. That's what we're going to be doing, but we're going to be using mathematics to cut along lines of symmetry. So we're going to start with two loops for this. Now that you have two loops, let me give you just enough time to make those loops if you're doing this along with us. And at any time, if you notice something interesting or have questions, if you'll pop those questions into the comment section, our staff will answer those for you. What we're going to do next is tape these loops together in a very particular way, so I want you to look at the document camera closely. One loop is going to go this way, and the other loop is going to go at a 90-degree angle. So check that out. You don't want it to look like a figure 8. You want it at a 90-degree angle. Another way we describe this in mathematics is perpendicular. And then you're going to tape this in place. Now, you get to use lots of tape today. I know at home a lot of times your parents will tell you don't use a lot of tape. You don't want to waste it. But today, we have to tape a lot. So I taped here, but guess what? On the other side is another place I need to tape to make sure my experiment works. So today is a day that you get to use lots and lots of tape. And I'll leave this here and give you a little time to make your next shape of two loops, one at a right angle or perpendicular to the other. All right, so now that you've got this, let's go to the main camera. I want you to hold it a certain way for me. I want you to hold it so that you can look through the bottom and the top loop is going the other way. Because what we're going to do is with this bottom loop, we are going to cut in a circle just like we did before. We're going to cut a line of symmetry just through the bottom circle first. Then we're going to cut the top. But before we start, what do you think it's going to look like if you cut along the line of symmetry just like we did on the bottom shape all the way around? What are you going to end up with? For parents or adults, if you're watching this, do this as well because it's a really great way to check those visualization skills that you have. You may find that your children in your home are actually better at this than you are, because so much of the work they do in video gaming and other things, they are visualizing all the time, which may not be as familiar a skill as it is for you as it is for them. So they may be better at this than you are. All right, let's go back to the document camera. I want to show you how to cut this because it gets trickier each time. So I'm holding my bottom loop. I'm going to smush it just like I did before. And right where I smushed it, I'm going to make one cut with my scissors so I get that cute little duck look. And then I'm going to open it up. And I'm going to cut right down the middle just like I did before. And when I get to the taped part, I'm going to cut all the way through it. I want you to do the same. Now don't look at mine until you've got yours all undone. And so yes, you cut all the way around and you cut through the tape and the other loop. And if at any point some things come untaped that you know should be taped, go ahead and tape them back. I've got one section that's coming loose and I know I want to keep that taped so you can add more tape. All right, everyone show me what you've got. I wish we were together. We could do this together. Check this shape out. Isn't that kind of weird? I had two loops and all of a sudden I've got this. Now a lot of times I see when I do this with kids, I see them do this. Or I see them do this. Or if they ride in the car with their grandparents, they think it looks like a cup holder in really old cars. So we've got this interesting shape. For those of us that are older, we know a cylinder can be translated or put into this shape. Now, the next thing we're going to do is we're going to cut this strip. It's not a loop anymore, it's now a strip of paper, right? We're going to cut it from top to bottom. But wait, don't pick up those scissors yet. I want you to visualize what this is going to look like. What is this shape going to be after you cut it? Now, I'm not going to go to the document camera because it does get bigger. I want you to go ahead and grab your scissors. I want you to start at the bottom, and you're going to cut a line of symmetry all the way up, just straight through the middle of that loop, from the bottom to the top, and you are going to cut through the tape. At home, at any point that you'd like to take pictures, we would love to see your images and your pictures of what you're creating. And even after this program, you may find that this is a little addictive. We'd love to see what you make. All right, everybody open it up. Let's see what you've got. Okay, the first time I did this, it freaked me out that I started with two loops and all of a sudden I end up with a square. That is really weird. But that's what I love about geometric transformations. I think we have time. Let's do 3 loops and let's see what we get. And then we'll use a very special loop. So for this, you'll need 3 strips of paper. And I want you to make 3 separate loops for me. I'll be making mine on the document camera while you make yours at home. If any time I go too quickly, all you have to do is pause and start when you're ready. All right, so now I have 3 loops, 3 strips of paper. I'm going to make 3 loops. So for many of us, no matter what part of the country and what part of the world we're in, geometry is a really important part of mathematics. And we usually study geometry after we spend a lot of time dealing with numbers and operations. But the study of shapes and their importance in the world is incredibly important in so many areas of life. The ability to take shapes and change them is important in video game making. It's important in any type of 3-dimensional models we make. And 2-dimensional models we start with in CAD. So the ability to change and manipulate shapes is increasingly important in the industries of today. So I've got my 3 loops. I'm going to give you just a little bit of time to create 3 loops. But if you're wondering what to do now and you're ready to move on, we're going to do the same thing we did before. We are going to take one loop, we're going to put the next one on top at a perpendicular angle, and we're going to tape it. Just like we did the first time, we're doing exactly the same thing we did the first time. And remember, there are 2 sides of the paper, and so we want to tape both sides. Once you get that done, you're going to add the next loop on top, just like a chain. and tape it in place. If there are grown-ups that are helping kids in the room, make sure that all the loops are at a perpendicular angle or 90-degree angle. After you finish this, I want you to put it on your head because I bet it will remind you of something. This is a great shot to send us. And again, if you're behind just a little bit, go ahead and pause this at any point. So what does this remind you of? Yep, for a lot of people, this reminds you of Mickey Mouse ears. Exactly right. All right, so now we've got to talk about how to cut this. Now, I'm going to take it off my head. It's easier to cut when it's not on my head. I want you to hold it up and down like this. And I want the two parts that you could look through to be on the top and the bottom so that you can see me. Now, this may not work really well if you're at home and there's just one or two of you at home, but then again, it might. I'm going to ask one person at your place, at your home, or wherever you're viewing this, I want one person when we start to cut, I want you to cut the top loop first. Then I want someone else at your house to cut the bottom loop first. And then we're going to stop. And guess what? I'm going to cut the middle loop first. So look around. If you have more than one person that's made this in your home, one person cuts the top loop, one person cuts the bottom loop. If you have 3 people watching this, someone else can cut the middle like I'm going to. Let's go to the document camera and talk about that cutting because it gets a little more complicated the more loops you add. So, no matter if you're cutting top or bottom, remember to make that smush. Make one cut and then open it up and cut all the way around, and you will cut through this loop. So that helps you no matter if you're top or bottom. And I'm going to cut the middle loop. And we're just cutting one loop and then we're stopping. All right, we can go to the main camera. All right, so you've cut one loop. I've cut one loop. Let's see if our things look the same or different. This is what mine looks like. Does mine look like yours? Not unless you cut the middle loop. So right now, we have different things. So I've got a question for you. Don't cut yet. I know you're wanting to pick up those scissors. Don't do it. Don't do it. Do you think you and I are going to end up with the same thing or different things? I cut the middle loop first. You cut your top or bottom loop first. I wonder if we're going to get the same thing or different things. Now, the next thing I'd like you to do, and it will get a little tricky, is you still have a loop, don't you? I'd like you to cut that loop all the way around. And I don't have any loops anymore, so I'm going to cut a strip. So let's take a little bit of time to do that. I'm going to go to my document camera, and then let's see what we end up with. But you're only going to cut, you guys are only going to cut one loop, and I'm going to cut one strip. Now in math, a lot of times when we deal with numbers, we talk about working backwards. And in geometry, we can do the same thing. You could actually take the shape you're cutting, and after you've cut that loop, is there a way you could work backwards and make it look like it did when it started? That's kind of a fun extension, is can you work backwards and create the shape that you started with? I'll show you what I mean. Can I take this shape and find a way to undo it and make it look like it when I started? We call this working backwards with numbers, but you can also work backwards with shape. So once you cut your loop, see if you can do that. It does get harder the more often you do it. So let that be a challenge, but not something that frustrates you. And what I want to do is see if I can make what you guys should have. So now I'm going to take my shape and cut it, and let's see what my shape looks like when I take a strip and I cut it from top to bottom. I bet. Let's have a look. Let's look at this in the real camera. This is what I have. Let's see what you have. I'm going to take my shape. I made another shape. I'm going to cut it. I'm going to show you, if you cut your top and bottom loop, what it should look like. Now, I will tell you, if this did not work out the way you wanted to, this is the one great thing about YouTube. You can stop the video and back up and just start over. So after your first cut, you got this funny little thing that looked like this, right? And then I asked you to cut the loop you had left. So when you cut it, you should end up with two shapes, right? This is what I bet you have at home, is two shapes that look like miniature cup holders, or miniature handcuffs, or miniature earmuffs. So right now, you have one thing and I have another, and our question at the beginning of this was, are we going to end up with the same thing or not? The only thing you have left to cut are these tiny strips on both your pieces. Would you do that for me? And I'm going to cut my middle strip. Let's see if we end up with the same thing or different things, because we cut in different orders. Right now, I'm cutting what you should have at home. Oh my goodness. I wonder if this is what you ended up with. It's two rectangles. Let me move those out of the way, and here's my shape. I'm going to cut it up the middle. And oh my goodness, even though we started at different places, let me go to the camera, we're going to end up with the same thing. We are going to end up with two rectangles. So in this case, order did not matter. Now, sometimes in mathematics, order is very important. But in this case, order didn't matter for us this time. All right, now, you can go down the best rabbit hole ever. And that rabbit hole is make 4 loops. Put them at 90-degree angles. What do you get? I wonder if you took 2 loops and put them at a different angle than the perpendicular or 90 degrees, I wonder what you would get. But we have to end our program pretty quickly, and I know I've kept you a long time, but this is my favorite loop. For this, all you need is 1 strip of paper that you've been using. If you need to grab another piece of paper like I do, you can cut another strip really fast. We can go to the document camera. So I'm just cutting another strip of paper really fast. We are going to make a really special loop. It's not a regular loop, it's called a Mobius loop, so I need you to look really carefully at the camera. I'm going to ask you to make a loop, but before you tape it, I want you to lift up the top, flip it over, and put it back down. So when you have this loop will have a little funny twist in it like this. Let me show you again. You start with the loop like this. You lift up one side of it, flip the paper over, and put it back down. And so when you tape it, you have a loop with a little twist in it for you. So go ahead and make one of those for me. That's what it'll look like. You have just made an incredibly special loop called a Mobius loop. It's named after a mathematician named Auguste Mobius. He was born in 1790, so he was born a very long time ago. He was a mathematician and an astronomer, and he spent a lot of time studying the surface of geometric shapes. He didn't care about the shape, he cared about the surface. He was the first person to write a paper about this shape, and so they named it in his honor. Here is the question he asked, and here's the question I'm going to ask you. So you're actually holding a math problem that's over 200 years old right now. His question was, How many edges does a Mobius loop have? And how many sides? So let's find out. And we'll use the same test we used at the beginning of our class. I want you to go grab your pen or your marker, and all you're going to do is make a dot in the middle like you did before. Make it nice and big so you can see it. This is how we figured out how many sides there were. We just do a straight line. So as you start to draw a straight line down the line of symmetry, because of that twist, sometimes it's a little harder, but just draw a straight line until you touch the dot again. For educators that are watching this piece, my favorite moment, no matter what, is about halfway through this, when almost every person, no matter what age, just stops and is so surprised. Yes, you go over the tape, and yes, it's hard to draw down the middle, so it doesn't have to be perfect. And just keep drawing until you find the dot. This is what makes a Mobius loop so weird. You have a line over every surface of this shape. But you never went to the other side of the paper, right? A Mobius loop is a one-sided object. That's what makes it so special. By just putting that flip in the paper, you've created a one-sided object. I wonder how many edges it has. A regular loop has 2. Let's find out. To do this, you need your finger, and you need to be careful so you don't get a paper cut. And I want you to put your finger right by the dot on an edge. And then I just want you to go around the edge and see what happens. It's like a roller coaster for your finger. Your finger can go around this edge infinitely. It can go around this edge, and you are hitting every edge of this paper. So this has one edge. That's what makes the Mobius strip so amazing. Now, this work of Mobius and others in his field at this time created a whole new area of geometry that's called topology. Topology doesn't care about the shape you've created. It cares about the surface of the shape. One of the jokes that topologists tell each other, I don't think it's a very good one, is that donuts and coffee mugs are the exact same shape to a topologist. They have a hole in the middle, and they're exactly the same shape or same thing to a topologist. Very weird thing to think about on a day like today, right? Now, what you can do later is take your scissors and cut along that line and see what you get. So, thank you so much for joining us for our geometric transformation program. If you have questions or comments, please add them to the bottom of the feed. We would love to answer your questions and see what you think. Good luck exploring all these fun transformations, and thanks for joining us for Discovery Lab Online. Check out our YouTube channel, where we'll be adding new programs each and every day of the week for our guests. Can't wait to see you at the museum or on Discovery Lab on Wheels soon. Discovery Lab Online soon, sorry. Bye.